Now, this is trying to find inference for a single proportion. This is taken from Chapter 9, it's problem 52. Part A says, find the margin of error for this poll if we want 95% confidence in our estimate of the percentage of American adults who approve of cloning humans. Now, according to the problem, that percentage is 8% or a proportion of 0.08. And this is the formula for margin of error. Z is your critical value times the square root of p hat times 1 minus p hat all over n. N being the total sample size. Now the Z value is 1.96. Multiply that by the square root of 0.08, which is p hat, times 0.92, which is 1 minus p hat, all over 1012, which gets a margin of error of 0.0167. Now, what a margin of error is, it basically means that the true proportion likely lies within a value of 0.0167 on either side of the sample proportion. So, since the sample proportion is 0.08, it's likely that the true proportion is somewhere between 0.0633 and 0.0967. Now, if we only need to be 90% confident, will the margin of error be larger or smaller? The margin of error will be smaller, since the critical value of a 90% confidence interval is less than the critical value of a 95% interval. The critical value being here, so if you put a smaller number in here, the margin of error is therefore going to be smaller. Now, to find that margin of error, you do 1.64 times the square root of 0.08 times 0.92 all over 1012, and you get a margin of error of 0.014. Now, in general, if all other aspects of the situation remain the same, would smaller samples produce smaller or larger margins of error? Now, see, a smaller sample would actually produce a larger margin of error, because if n is a larger value, then you divide the margin of error by a larger number, you'd end up getting a smaller outcome. Say, if you make this a bigger number, then the total is going to be smaller. This will remain constant. And the bigger the number this is, the smaller this total value will be.